Alright, geometry. Welcome to a little tutorial on Unit 2. We're going to be talking about parallel lines and the coordinate plane. Let's get started, not wasting time here. So one of the first things that we need to be able to do is identify relationships. And these relationships are going to be fitting. The ones that we need to be aware of are corresponding alternate interior, alternate exterior, and same side interior. So let's look at what we have here. If I'm just going to be doing some examples straight out of the problems that we have. This first one here, it has an example of two angles that are corresponding. How do I know that? Well, I know the relationships first of all, but a second thing that I like to think of is a copy. If I look at this angle and then the other angle here, it's almost like it was copy and pasted. It's not moved, or it is moved, but it's not rotated or translated anywhere except, just directly across from it. Alright, this one here, we have two angles. They're on the same side of the transversal. The transversal is this line that's cutting across. They're on the same side of that. So the only one of these that has same side would be the same side interior. And I also know that it's interior because they are inside the parallel lines. So these are same side interior angles. There's a lot of different ways that you can draw these pictures. These are just a couple of examples, but those are two that you can check for yourself and see. Alright, find the measure of each angle indicated. Well, first of all, I look at this one and I know that it's corresponding. On number 7 here, I know it's a corresponding angles relationship. I also know that corresponding angles are congruent. Therefore, if this is 51 degrees down there, this is also going to be 51 degrees inside. Let's make the pen a little bit smaller here. Similarly, we have a pair of angles here, and they have a relationship. This is the same as the relationship we were just looking at. This is same side interior. So we had a corresponding and a same side interior. The difference for the second one is the relationship isn't going to be that they're congruent. Instead, they are supplementary. Angles that are supplementary add up to 180. So when I look at these two angles, I see 60 and then this question mark. And 60 plus that question mark is going to equal 180. So if I were to subtract 60, I would figure out that the question mark was really 120. So this angle down here is 120 degrees. Alright, this last one here, number 11, these are alternate interior angles. And alternate interior angles are congruent. They're the same. So if this one's 95, so is this one. Now let's continue with these relationships, but at a slightly more challenging level. All right, here the relationship we see is alternate exterior angles. Whenever angles are alternate interior, alternate exterior, they are going to be congruent. So that means that 60 degrees and this x plus 68 are going to be equal. So 60 equals x plus 68. Now this is kind of weird because when we subtract 68 from both sides, we're going to get negative 8 equals x. And when you think of geometry, negative answers don't tend to make sense. Well, the x is negative, but the entire value of this angle is still going to be negative 8 plus 68. That's still going to be positive. If I plug it back in and check, it is indeed the same as the other one. This next set is going to have a similar attribute where we're going to come up with a negative answer, but it's still going to be a positive angle for this measure that I just colored in. So look at these two angles. They are same side interior angles, and same side interior angles are supplementary. Therefore, x, or 105 plus the other angle, which is x plus 85. It's going to add up to 180. So let's group things and see if we can get this x by itself. Well, first I see that 105 and 85 together, that's going to make 190. So that means when I subtract 190 from each side, I'll get x equals negative 10. So that's, again, a negative answer for x. And that's all it's asking us to do up here, solve for x. But when I plug it back in, if I were to plug in negative 10 here, negative 10 plus 85, that indeed equals 75. It's a positive answer for our measure, so we're still okay. Alright, let's look at now putting those two steps together. Knowing the angle relationship, finding x, and then plugging it back in. Okay, so notice it's asking us to find the one that's in bold, which in this case is this one down here. Well, what I notice when I look at these two angles is that they're alternate interior angles, and alternate interior angles happen to be congruent. And that means that if I have alternate interior angles that are congruent, I can set these two equal to each other, because that's what congruent means. It means equal. So that tells me 23x minus 5 is equal to 21x plus 5. Now if I regroup things, I'll put the 5's together here and put the x's together over on the other side. That means I'm going to have 2x on the left side. Those 5's make a 0. And these 21's make a 0, but the two 5's make a 10. So now when I solve for x, when I get the x solo all by itself, I'm going to get x equals 10 divided by 2, which is 5. That's not the actual answer. It said find the measure. Those three words, find the measure, tell us to plug it back in. So I got to plug this back in. Now it tells me to find this one down here. So I'm going to plug it in there, even though it doesn't really matter because they're equal. So I'd have 23 times 5 and then minus 5. That's really the same thing as 22 times 5 because I got 23 of them here and 1 here. But let's go ahead and figure it out. 23 times 5 is, let's see, that would be 115. And we subtract 5. That's going to be 110 degrees. So this angle is 110 degrees. Alright, let's take a look at these ones. It's going to be similar because if you look at these two angles here, these would be corresponding. And they're corresponding angles, so that means that they're going to be congruent or equal measures. So then 12x plus 12 equals 14x minus 6. Now I got to regroup the x's and the numbers, the constants. So I'm going to add 6 to both sides. I'm going to subtract 12x from both sides. It's going to give me a 0 with the 6's and a 0 with the 12's. This 12 and 6 put together, though, is going to make 18. This 14 and negative 12 is going to make 2x. When I divide by 2, I get x equals 9. X equals 9, but I got to plug that back in, and it's asking me to plug it into this bolded one up top. So I'm going to do 12 times 9 and then add 12 to that again. So 12 times 9 plus 12, altogether that's going to equal 120 degrees. So this angle and this one as well are both 120 degrees. Remember, if you need to slow down or restart or check an answer, just pause the video, rewind it. It's at your pace, but I'm not going to slow down because I want to get it finished. Let's keep on moving. Find the measure of the indicated angle that makes U and V parallel. So they're not parallel per se, but if this question mark were a certain value, then they would be. So what connects all those things together? Well, if I look at these two angles, that would be same side interior angles. And those are going to be supplementary. That means that the two angles are going to add up to 180. So that means 121 plus this question mark is going to equal 180. Let's see what the question mark would be then. If I subtract 121 from both sides, I would get the question mark to be equal to 69 degrees. Not 69 degrees. Is it 59? It is 59. I forgot to borrow. So it's 59 degrees. 5, 9. There we go. Excellent. Let's look at the second one. Oh, what reference could we say that makes those parallel? We would say it's the converse of same side interior angles makes those two lines parallel, if that were 59. Now when I look at these two angles are corresponding. And corresponding angles need to be congruent. So if that's 91, then this one should also be 91 degrees. It's that easy. It's kind of a backwards way of thinking, but still using the same relationship. All right, now we're going to jump into the idea of midpoint. Midpoint. Midpoint is really the middle. And there's a lot of ways to describe the middle, especially if you take like a statistics course, but here we're interested in the exact middle, the numerical or arithmetic middle. So I know it's somewhere around here. Now how could I actually figure out that point? Well, if I look at these two coordinates, this coordinate here is at -2, 1. And this coordinate here is at 5, 3. So what I want to do is find that value right in the middle that's between those. Well, how do I find the number that's between two other numbers? It's actually called the average. For example, if you were to score 10 points on a test one day and 20 points on a different test the next day, the average would be 15. It's that number right in the middle. How do we find it? You add them up and divide by the number of pieces we have. We have 2 points here. So the average point, the one in the middle, the midpoint, is going to have an x and y coordinate. And this x and y coordinate is going to be made up of the averages of these numbers. So I'm going to start with x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So if I know those, that's the average, add them together and divide by 2. It's pretty easy to find. Well, the x's are 5 and -2, so that's going to be 5 plus -2 divided by 2 for my x value. For my y value, similarly, it's going to be 3 plus 1 divided by 2. Well, let's simplify these. 5 plus -2, that's 3. So this is 3 halves. The other side, that's 4 divided by 2, or just 2. Now, you might see this written as a decimal. If that were the case, it'd be 1.5 and 2. Or if we were to write as a mixed number, it'd be 1.5 and 2. All of those are really the same number, though. All of them are the midpoint. All right, let's look at the next one here. Find the midpoint of the line segment with the given endpoints. Ooh, so they're not going to give us a picture, just the numbers. Well, but if we remember what we were just looking at, we had a formula. It had like x1 plus x2, the x's divided by 2, and the y's divided by 2. Well, here's our x's, and here's our y's. So let's add the x's. 2 plus 8 divided by 2. That's really 10 divided by 2, or 5. So that's my x value. For my y values, that's 10 plus -6 divided by 2. Well, 10 plus -6, that's 4 divided by 2, or just 2. So that would be my answer for this one, 5, 2. Let's do the other one, same idea. We have x's, we have y's. Let's put them together and find the average. -5 plus -8 divided by 2 is going to be one of them. And the other one's going to be 4 plus -5 divided by 2, of course. Let me erase that out of parentheses. Not necessary. There we go. So now if I simplify this, -5 and -8 is going to be -13 divided by 2. 4 and -5, that's going to be -1 divided by 2. So that could be an answer. If I needed to give it in decimal format, it'd be -6.5, -0.5. If I wanted to give it in mixed number format, this would be -6.5, and here we'd have -1/2 again. All three of those correct, all three of them the same number, just different ways of writing it. Now here's where we get a little bit different. It says find the other endpoint. I'm going to show you how to do one of these visually, and I'm going to show you how to do one of these algebraically. Both ways work, both are fine, both get the right answer. So let's start with the visual. I want to give myself an x and y axis just to kind of sketch what's going on. So I got a vertical line and a horizontal line. It says an endpoint is at 10, 1. So that's somewhere at about here at the point 10, 1. And this is an end point. The midpoint is at -8, -8, around here. So that's a midpoint at -8, -8. So when I look at this one, I see that there's going to be a line that's connected by these, but this is only half the line. And then the question is, where's the other half? Is the other half over here on the right or on here on the left? Well, these two labels are going to help us reference that. the end point is going to be an end. It's not going to go anywhere past it. The midpoint is the middle and is going to show us where the other side should be going. So the other side should be going somewhere out here. Then we're going to ask ourselves, well, how far is it going to go? Well, let's look at where we are and how we got there. The middle is at -8, -8. And we got there by moving from 10 over to -8. So that's -18 in the horizontal direction. Move -18 left. And then we also moved from 1 down to -8. So it's going to be -9 in the vertical direction as well. So that means we have to move left -18 and down -9 again from this middle. So let's start with -8, -8. We're going to move left -18. We're going to move down -9. So if I add these movements into here, that's going to give me -26 and -17. That's a pretty big movement. It's way down there, probably off the screen. Alright, this next one, I'm going to show you guys how to do it algebraically. It's kind of more based on a formula, and for some of you that might work, but I don't suggest sticking only to the formula. Pictures always help explain. Oh, push the wrong button there. Turn the touch screen off. Alright, here we go. We have an endpoint and a midpoint. We know that the endpoint has, let's call this x1 and y1. And this midpoint is our x in the middle and our y in the middle. And I know that my x in the middle is equal to x1 plus x2 divided by 2. Let's plug in the pieces I do know and solve for the third piece that I don't. I know that the middle x is -7. I also know that the first x here is 4. Then we have plus x2 all divided by 2. Now notice I could solve this equation and solve for x2 and get what that x value is. Let's see what it would be. Well, I got to multiply both sides by 2 to get rid of that denominator and simplify it to just a 1. So that means I got -14 equals 4 plus x2. If I subtract 4 from each side, that's going to give me -18 equals x2. So there's my x value, but now I got to do the same thing for the y value. My y in the middle is equal to the sum of the y's divided by 2. Well, the y in the middle is 5. And the x, or the y1, is going to be -5. So it's going to be -5 plus y2 divided by 2. I gotta go through the same process. Multiply both sides by 2. Gives me 10 equals -5 plus y2. And if I add 5 to both sides, that's going to give me 15 equals y2. And this might seem a little bit simpler, but it's also a little bit easier to make a mistake just because you have to get the formula right. So let's go ahead and put these two things together here into an ordered pair. X is -18 and y is 15. There we go. Keep on moving. Find the distance between each pair of points. Ah, distance. Distance is really Pythagorean theorem. So let's do that. I'm going to draw a triangle here. So this will be turned into a triangle with a right angle corner, and I just got to figure out the two sides of the triangle. Well, if I look at the triangle, this goes down to -5 and it goes up to 5. So this side is 10. If I look at across the top, this horizontal line is from -4 to 4, so that side is 8. And if I look at my Pythagorean theorem, a squared plus b squared equals c squared, then the a could be 10 and the b could be 8. Then we have 100 plus 64 equals c squared. That gives me 164 equals c squared. Now, as I'm looking at this, I might want to ask myself, can I reduce that? Can I bring out any numbers? Well, let's take a look. I know that I can take out a 4. Let's see how many times 4 goes into 164. It goes in 4 and 1, 41 times. So 4 times 41, because I'm going to wind up square rooting all of these. And then if I were to simplify that even more, it'd become 2 times square root of 41 equals c. Now we want to really be good at simplifying our radicals here, because a lot of times in a multiple choice exam, you're going to see it simplified in this format. All right, find the distance between each pair of points. One of these I'm going to do with a picture. The other one I'm going to do algebraically, like we did kind of before with the midpoint. So in this picture, I have -3, -7. There's a point down here. -3, -7 is where that point is. And it goes up to 3, 3, -3. So about here. This is at 3, -3. So we have this diagonal line here. So I'm going from -3 to 3 in the horizontal direction, so that's a distance of 6. And then the other direction, I started at -7 down here on the bottom, and I went up to 3 here, so that's a distance of 4. So when I do my Pythagorean theorem, I know that 4 and 6 are a couple of my numbers. Here, the two legs, so that's what I'm plugging for A and B. That gives me 16 plus 36 equals c squared. If I add those two together, it gives me 52 equals c squared. Well, that's the same as 4 times 13, is that right? Yeah, 4 times 13. So I'm going to square root each of these, then I'm going to factor it. It's going to be 4 and a 13. Oops, does not equal c squared, just equals c. And square root of 4 is 2, so that's going to be 2 root 13 equals c. I'm going to show you guys how this works, kind of by shortcutting it. A little bit with the formula, but more by just understanding a squared plus b squared equals c squared, the whole Pythagorean theorem. Notice that one of these, the a we've been using as like our vertical distance, and b we've been using as our horizontal distance. Doesn't really matter which one is which. And I do in the end wind up square rooting whatever I do there. So the square root of a squared plus b squared equals c. So I'm going to have the big square root of something squared plus something squared equals c. Now the trick is to know what goes in for a and b. Let's look at the vertical distance first. We move from -3 to -5. Well, that's a distance of 2. And when I'm moving from 7 to -7, that's actually pretty far. That's a distance of 14. Now I can look at this a little more carefully and start to simplify. So 2 squared, that's 4, and 14 squared, that's 196. So I'm going to add those together. It's going to give me 200. I'm still square rooting it. But the square root of 200 is really 102 if I were to split it up into two factors. And the square root of 100 is 10. So 10 square root 2 equals c. Or our distance. Distance. This is our distance. Because that's what we're finding. Remember, distance, Pythagorean theorem, same difference. Next. Find the slope of each line. Alright, this is middle school at most. A lot of you guys should be able to see the rise and run of a slope. Well, the rise here, the difference in the vertical direction is 2, and in the horizontal direction we go 1, 2, 3, 4, 5, 6. So the slope is going to be equal to 2 over 6. Now this would probably be simplified. It would probably say 1/3. There we go. Find the slope of the line through each pair of points. Ooh. Well, I'm going to do again one of these with a picture and one of these algebraically, just so you guys see a combination of what's going on. Let's do first the one with a picture. So I have a picture here. I have 10, -13. So I'm going out 10 and down -13. I have a point here. 10, -13. I also have a point at -3, 19. Wow, so that's pretty far up there too. -3, 19. So if I'm trying to find the slope, first thing I notice is that it's going to be negative. Then I just got to figure out how far down and over does it go. Well, I start at 19 and I end up at -13. So that's 19 and then 13 more. If I put those together, that's going to be 33. 2. So the top is going to be a 32. The bottom, we start at 3 and we end up here at 10. So that's a total of 13. And this fraction is actually as reduced as far as it will go, because 13 does not go into 32. Now if I wanted to do this not necessarily visually but with more of a formula, there is a formula for slope. We usually say that slope, we call it m for our slope, is equal to the difference in y's over the difference in x's. Because that's how you measure how far you've moved. You take the difference, you subtract. It's like saying if I started at 2 and I went to 23, how far did I go? I went 21 units. I subtracted 23 minus 2 gives me a movement of 21. We're doing the same thing when we're looking at slope. We're looking at movement. I think that's where they come up with the letter m. So let's use these x and y values to calculate that movement. So first I got 16 minus negative 5 for my y's. And then for my x, I have 20 minus negative 6. Let's see what this would simplify to. The top is going to become 21, because this is really a positive when you have subtract a negative. The bottom is going to become 26. Those don't have any common factors, because this bottom would be 2 times 13, top would be 3 times 7. So there's relatively prime. That means that the slope equals 21 over 26. Find the slope of each line. This is purely knowing the format that it's in. It says y equals mx plus b. And we're looking at that slope. So in this case, it's 4. In the next case, it's negative 3. Or pardon me, negative 4 and then negative 3. It was that fast. Next, find the slope of the line parallel. Parallel means that it has the same slope. So let's look at these slopes. For this first one, it's going to be negative 2. The slope of the parallel line is going to equal negative 2. For the next one, it's kind of different. If we're thinking y equals mx plus b, well, there's no x. Where there is, in fact, it's a 0x. It's 0 times x minus 1. So b is really negative 1, but m is 0. So the slope is equal to 0. Find the slope of a line perpendicular. Perpendicular means we're going to flip it and change the sign. The sign is it positive going to negative or negative going to positive? So I take this number here. I got negative 4. It's really negative 4 over 1. I'm going to change it. I'm going to flip it and make it positive. And then that would be my slope. 1/4. This next one, I have 9 over 4. And what I'm going to do is I'm going to take 9 over 4. I'm going to flip it. And I'm going to change the sign. So it's negative 4 over 9. That's what we do when we find something perpendicular. Sketch a graph of each line. Okay, x-intercept negative 4, y-intercept 1. All we got to do is make those 2 points and sketch a line through them. That's all we're looking for. No big deal. Let's try another one. Ooh, now we got something here. This is in slope-intercept form. Y equals m times x plus b. Notice that we have 2 ingredients here, the slope and the y-intercept. So negative 2 is our y-intercept. That's down here. And this slope, 1/2, tells us how our movement's going to go. We're going to go up 1 and then over 2. And up 1, over 2, and so on. And it continues back the other way as well. So let's go ahead and draw a semi-straight line through all that. There we go. That's a sketch of our line. Write the slope-intercept form of the equation of each line given, the slope and the y-intercept. So all we have to do is interpret these two things into an equation. Slope-intercept form is always going to be something times x plus the y-intercept, the other piece. So all I got to do is fill these in. So it's literally negative 8 over 3 plus negative 5. Now, on a multiple choice test, you won't see it where they have 2 signs next to each other right there. It would be simpler. It'd say negative 8/3 minus 5. Oh, negative 8/3 x. Pardon me. I'm forgetting the x. Hopefully you guys noticed that. Number 78 is similar. It's going to be y equals, well, we take the slope, so that'll be negative 5 over 4x, then the y-intercept, which is going to be plus 0. Now, this one will probably be simplified again in the multiple choices. Be negative 5 over 4x, and that's it. It wouldn't have any plus 0, because you don't have to write it. Write the slope-intercept form of the equation of each line. Okay, well, notice something about slope-intercept form. Y equals mx plus b. The y is by itself. You got to solve for the y. You got to get it by itself somehow. So we got to remove all the other pieces, all these coefficients, all these other terms away from that y. So the first thing I'm going to do is move this x. So that would give me negative 7y equals negative 10x minus 49. Now if I divide everything by negative 7, that's going to give that negative 7 simplified down to just y. Up here, this negative over negative is going to be positive, so we have 10 over 7x, and then negative 49 over negative 7 is positive 7. Now for number 82, I'm going to use some clever moving around, because when I look at this, I really see that the y is almost by itself. I just got to make it positive on the other side. So I'm going to add y to both sides. That would give me x equals y minus 1. Then I'm going to add 1 to both sides. Then x plus 1 equals y. Now I know this might not look the same because it's almost backwards, the y is on the right, but y is by itself. So I could even rewrite this. It's y equals x plus 1. Same thing. Write the point slope of the form of the equation of a line through the given point and the given slope. Okay, so point slope form is going to be y minus y1 equals the slope m times x minus x1. So as I'm looking at this, I really just need to fill in the y value, the slope, and the x value. Well, let's plug them in. The y value is here, that's negative 5. The x value is here, that's 5. And the slope is undefined. Ooh, undefined. That's like something over 0. That's kind of weird. Well, if slope is undefined, that means we have a vertical line. And if we have a vertical line, that means that x equals something. And in this case, the x value is 5. It's kind of a different question. You don't see this one too often. But slope undefined is telling me that it's going to be x equals some number. And I just got to figure out what is that number. And in this case, it's 5. This next one is going to be a little more straightforward. Let's see if we can get it worked out correctly here. So all I got to do is fill in the y value with negative 1, fill in the slope with 1, and the x value with negative 5. Now if we were to simplify this, these two signs would be combined into 1. So they would say y plus 1. Here, this 1 probably wouldn't even be written. It would just be x minus, or actually plus 5. We could say times 1, but that probably wouldn't be there. Write the point-slope form of the equation of the line through the given points. Well, point-slope, remember, is y minus our y value equals our slope times x minus our x value. So I don't know my slope. I need to find it. Well, if you think back to that formula, the slope is equal to the change in y's, the difference in the y's over the difference in the x's. So let's look at that. Here's our x and y, x and y. So how much is there a difference in the y's? Let's find out. Negative 5 minus negative 3. And the difference in the x's would be negative 3 minus 0. These two negatives are going to become one sign. It's going to be a positive. Negative 5 plus 3 is really negative 2. And on the bottom, it's going to be negative 3. So that, if I simplify even more with two negatives, one on top, one on bottom, that would just make 2/3. Now for my y value, I can choose either one. I'm going to choose the second one. No reason, just because. So then I'll have y minus, the y value is negative 5. Equals the slope, which is 2/3, times x minus the x value, which is negative 3. Now to simplify this, because we got double signs here, we usually only have single signs. Let's going to be y plus 5 equals 2/3 times x plus 3. Not too bad at all. Alright, let's do this last one here, and then I think we have one more page and we're done. Okay, so we need to find the slope. What does the slope equal? Well, we know that it's going to be the difference in y's over the difference in x's. Let's find that out. The difference in y's is -3 minus -4. And the bottom here is going to be the x's, -5 minus 5. So -3, we got a double sign here. Let's make it a single sign. -3 plus 4 is 1. -5 minus 5, that's just two negative 5s there. It's -10. So it's -1/10. This time I'm going to use the first coordinate for my x and y value. So when I plug them in, I'm going to have y minus a y value equals the slope times x minus an x value. The slope is -1/10. The y value is -4, and the x value is 5. Now if I were to simplify it, these two negatives would combine. We'd have y plus 4 equals -1/10 times x minus 5. That would be the final answer. Alright, here we go. So we want through this point, but parallel to this line. And remember that parallel means same slope. So all we need to do is the point slope form of the equation, y minus something equals our slope that we need times x minus something. That y minus the y value is going to be 3. The slope is going to be the same because it's parallel, so that's 3 as well. And then the y value is going to be right here, so 3. Well, that's kind of interesting. Oh no, x. What am I missing here? It's the x value. The x value, which is 1. So it's y minus 3 equals 3 times x minus 1. Alright, for this next one, it says that we want to go through 4, -4. That's my x and y value. And here's my slope is again parallel to this equation. So the slope is -3/4. So let's go and plug it in. It's going to be y minus my y value, which is -4, equals the slope, which is -3/4, times x minus the x value, which is 4. Now if I were to simplify this double sign, it'd be y plus 4 equals -3/4 times x minus 4. That would be the answer you would see on the test. That is the end. Go back and check again anything that you need to see more than once. Thank you and have a good night.